Okay, multiple topics in today's lesson. We're going to talk about how many ways can we arrange things. We're going to talk about finding equations that have certain answers specified, designated roots. And we're going to talk about something called the overall average rate. So 3 totally different topics, but about average length on a lesson. So first off, some vocabulary. Permutation is just a way of arranging people or things that are in some group. So the places where you are seated right now is one permutation of the students in this classroom. If I had my 2 Ryans change places, that would be a different arrangement of you guys, so it would be a different permutation. To figure out how many permutations there are, we can use the fundamental counting principle. So if we have A different ways we could make a first choice or fill a first spot, and then B ways to fill the next spot, we'd have A times B total ways of arranging those. So if I wanted to arrange the letters A, B, C, and let's suppose that these were Scrabble tiles, and I was all out, so I couldn't draw 4 more to have the usual 7. And I'm trying to, well, how many ways are there to arrange them? Some may be words, some may not be. I can only use each tile once. I can't put the letter C in the first and the last spot. Wherever it goes, I've only got one tile that has a C on it. So for my first tile, how many letters can I choose? How many choices are there? There are 3 things I could pick for my first letter. After I've picked it, how many are left for the second choice, for the middle letter? And then how many? So I would have 6 permutations of those 3 letters, as long as I can't reuse any of them. If I wanted to, since it's such a small list, I could actually write down what those are. I could pick A first, and then B, and then C, or A first, and then C, and then B. Or I could pick B as my first letter, and then I could have A and C, or C and A. Or I could pick C as the first letter, and then A and then B, or C as the first letter, B and then A. So there are my 6 choices. And it looks to me like if it were Scrabble, I've only got one 3-letter word I could actually make. Others may be abbreviations or acronyms. But does that make sense? And you more or less remember doing some of these in past years? Okay, let's run through some other examples just for a little bit more practice with these. So if I have the numbers 3, 5, 7, and 8, and I want to put them in order, no repetition is allowed. So like the Scrabble tiles, or maybe I get a summer job helping to paint houses, take the house number off so we don't get paint all over it, and then it's time to put it back up, and I've totally forgotten what the street address was. My boss left and took all of the paperwork that had it printed on there. So there's only one correct street address. All the other things I might come up with will be wrong. I wonder what my chances are with that. So how many choices do I have for the first number? 4. Once I've picked that first number, how many choices are left for the second? And so if I multiply those together, 24, and I'm going to label it with how many ways, so 24 ways. So only one of those ways is the right address. The other 23 are wrong, and my boss won't be happy. Sometimes, though, we have as many copies of the letter as we need. We could get as many as we want, but we're only going to use the letters in the word equal. So E, Q, U, A, L. I've got 5 different letters I can use. I want to make signs that have 4 letters in them. So 1, 2, 3, 4. How many letters can I choose from for my first letter? 5. Repetition is permitted. How many choices do I have for the next letter? Any of those same 5. And then, so what is 25 times 25? 625, and these are how many signs, so I label that. Okay, a shorter midterm than what you guys took recently. Only 8 questions. A, B, C, D as your possible answers on those. So let's see, 8 questions. So 1, 2, 3, 4, 5, 6, 7, 8. How many answer choices do you have for the first question? 4. Now, if you answer A for the first one, does that mean you can't answer A on the next one? So repetition is fine. This problem did not say yes or no. We had to think about the context. So how many choices for the next answer? And so on, and so on, and so on, and so on. So let's see, 4 to the 8th is going to mean that we have 65,536 sets of answers. Only one of those 65,000 plus is 100%. Maybe more than one way of getting an A, but there's only one way to get 100% on those 8 questions. So moral of the story, don't just guess randomly, study. Don't guess randomly on every question on a test. Everybody good with that? Any questions with permutations? We will do more with them in future lessons, but for right now, that's as hard as it's going to get. So let's totally change topics, and we are going to move on to designated roots, which means you are going to be having questions like this, which we'll come back to in just a moment. The answers need to be -3/5 and 1/2. I want a quadratic equation that starts off with a lead coefficient of 1, so x squared, and it needs to have x equals -3/5 and x equals 1/2 as the final answers. So to get there, we're going to first review what it means to solve by factoring. So I have an equation, matches what I'm trying to get up to, 1x squared, and it's equal to 0. It's not just an expression, it's a whole equation. So I can factor this. And raise your hand when you can tell me the factors, and I'm waiting for most hands to be raised. Avery. +7 and -4 would give us that quadratic equation, right? We started both of these with an x so that when we multiply them, we get the 1x squared. That means our solutions are x equals -7 and x equals +4. So if we started with this, like on that one we're going to go back to now, to get the factors, I had to take the opposite of the root. When the answer was a -7, I needed a +7 to go in here. When the answer was a +4, I needed a -4 to go in the parentheses. And then I have to make it equal to 0 because that's the only way that the factors work. So that's what we're going to do on designated root problems. X as the start of each parentheses, opposite of the roots, equals 0. So for this one, that means, since we want the lead coefficient to be 1 in front of the x squared, the parentheses have to have just x in them. The opposite of -3/5 is +3/5. The opposite of +1/2 is -1/2. But now we need to get that into 1x squared plus bx plus c form. So we need to FOIL that and combine any like terms. So x times x is x squared minus 1/2x plus 3/5 x. Plus times minus is minus, what, 3/10 equals 0. Don't let me make any mistakes with pluses or minuses or anything. So far, so good. Okay, these two are the like terms, so it looks like I need a common denominator of 10. So times 5 and times 5 and times 2 and times 2. So I've got x squared minus 5/10 plus 6/10, so plus 1/10 x, and minus 3/10 equals 0. And that is our answer, even though it has fractions in it. Even though it is equivalent, and when we start doing some other kinds of equations, there will be times when we get rid of fractions. Your answer to this is not 10x squared plus x minus 3 equals 0. Even though that would have the same roots, it does not start with 1. The directions said that this must start with 1. Does that make sense? I need those textbooks closed. This is not a time to start on homework. Any questions there? Jack? They're generally wanting it in the ax squared plus bx plus c equals 0 form. And because you've got to set this equal to 0 when you're writing the factors, why would you want to do one extra step in there? Just leave it equal to 0. Anything else? Okay, one last topic for today, something new, overall average rates. So rate times time is distance, so rate is distance over time. Now, what this is talking about, maybe you are taking a trip, and maybe this is going to be the distance from home or something. And let's suppose we're just talking about the overall average rate for the second day of the trip. So the first day, you got some distance away from home, whatever that might be. And then maybe you started off and you were, on some streets where maybe the speed limit was 50 miles an hour. And then we started before breakfast because we wanted an early start, but then I started getting hungry. So I decided to stop for a while. So during the time that I am stopped, the clock keeps ticking, but I don't get any farther from home, do I? And then maybe I get on a highway where I could go 75 miles an hour for a while. Maybe I then hit an accident, and so traffic's barely moving, and then I get to a point where they're actually directing us to turn around, and we have to backtrack for a little bit to get to another road, and then we can start going on our way again. Now, we're not going to be drawing the graphs on these kinds of problems, but you kind of get the idea of what I'm talking about. We've got a trip, and we're going different speeds for different parts of the trip. Okay, for this part where I was stopped, what is my speed when I'm stopped? 0, so my rate 0. What's the slope for that flat part? 0. The slope is your rate of change. It is your speed, your distance over your time. If I want the average rate, the overall average rate, I'm not saying what was the speed on this little part. I want to know if I went from the starting point to the finish point, what was my slope for that line? That would be my overall average speed. I'm not going to take 50 plus 0 plus 75 and then divide by 3 or however many I have. Because maybe I was only going 75 miles an hour for 5 minutes. That should not be weighted equally to the 50 miles an hour that I was going for 7 hours. So how long you're at each speed makes a difference. So in order to get this, if I wanted that overall average speed, I'd want the slope of that line. So I would be talking about this rate of change. This would be the distance from where I started to where I ended that day. The total distance. Rise over run would be the time of the entire trip. So kind of have an idea of what we're talking about with these. So we're going to be doing some problems that look something like this. So we've got different legs of this trip. So for the first leg, we go 100 miles at 50 miles per hour. For the second leg, we go 180 miles at 60 miles per hour. And for the third leg, we go 120 miles, and we do not know how fast we're going. Overall, though, the total trip is going to be how long? How much? So 400 miles is the total distance. And I don't know anything about how long the trip takes. So I'm going to have a little bit of trouble then using this formula that my overall average speed has to be my total distance over my total time. I know I want my overall average rate to be 60. I know my total distance is 400, but how am I going to get the times for that trip? Can anybody tell me how long the first leg took? Grace? So if we take the distance divided by the rate, we were driving for 2 hours for that leg. What about the second leg? Anna? It's going to be 3 hours, 180 over 60. And we don't know what that third time is going to be. If this is x, I do know that the third time is going to have to be 120 divided by whatever that x is that I'm finding. Right? So what I do know is that my total time is 2 plus 3, and I don't really want to do a complex fraction in here. So for right now, I'm just going to say my third time, like that. I can solve that for the time that that third leg took. So let's see, if I do my cross product, I get 400 equals 60 times 5, so 300, plus 60 times T3. So 100 is 60 T3. So T3 is 100 over 60, 10 over 6, 5 over 3, and I'm not going to round that to a decimal because I still need to use it to figure out my speed on that third leg. And I don't want to reuse a rounded value. So now I know that 5/3 equals 120 over x. So I know 5x is 360. So what's 360 divided by 5? Somebody help me out. What do we get? 72, and these were miles per hour. And then let's stop and think, does that make sense? If we go for a while at 50 miles an hour, and then a while at 60 miles an hour, and then we go at something even faster, 72 hours, does it make sense that it might average out to 60 miles per hour, since that's what we were told we needed to have? So always kind of ask yourself, does my answer make sense? If I'd gotten 45, would that have made sense? Because I can't go at 50, and then at 60, and then something even slower, and have those average out to be 60. So always ask yourself those common sense questions. Any questions on today's lesson? All right, then we are finished. And you guys already have the problem set papers, correct?